And welcome back to science, everybody, and forces, fluids, and density. Last lesson, we took a brief look at what particle theory was, and today we're going to be looking at two particular quick things. I'm going to keep this lesson short. We're going to be looking at what a fluid is and what viscosity is. All right, so throughout this video, in about 5 minutes or less, we're going to look at those two items. So we can define a fluid as any matter that has no fixed shape but takes the shape of its container. So in other words, a fluid is anything that doesn't have a fixed shape. It doesn't have a shape that is always the same, but it will take the shape of its container at some point. Or it will take the shape of its container, for instance. So that would mean like carbon dioxide would be a fluid because it will take the shape of its container. It will fill that entire space of that container. Or water. Water is a fluid, it will take the shape of that container. Or maple syrup, it will take the shape of that container. Air and oxygen, it takes the shape of whatever room we're in. It fills the entire space of the room in which we are in. And now we're looking at viscosity. Now, how fluids flow, whether that's a gas or a liquid, how they flow is determined by something called viscosity. And what viscosity is, it is the internal resistance or friction that keeps it from flowing. So we know something has a lot of friction, it's hard to move across that. For instance, if you were to put your feet on sandpaper, your hand on sandpaper, and you're going to try and move your hand across that sandpaper, there's a great deal of friction, so therefore your hand does not move very smoothly or easily across that sandpaper. So therefore, there's a lot of friction. However, if you put your hand on a tabletop with butter on it, it would move very smoothly. So it would have not a lot of friction. Well, within liquids, for instance, within something like water or maple syrup, there's particles within there. And if the way those particles are organized, there is more or less friction. More particles are either rubbing up against each other or less particles are. For instance, in water, there's not a lot of internal friction within that water. So therefore, things flows through water fairly smoothly. However, in a jar of maple syrup, there's a great deal of internal friction or resistance within that, so things don't move so smoothly through it. For instance, if I were to drop a fishing hook in water, that fishing hook would move through that water very quickly. If I were to drop a fishing hook into a jar of maple syrup, that fishing hook would take a long time, if it could at all, to go through that and sink to the bottom because there's friction and resistance of the particles within there. And so, in other words, viscosity effectively means kind of in lay terms how thick a fluid is. So, if something has more friction or more within that fluid, it is more viscous. It has more internal resistance. If it has less friction, it is less viscous. It has less internal resistance. So if something does not have a lot of internal resistance, nothing's holding things back from moving through it, you would move through that liquid very quickly. However, if something does have a lot of internal resistance and there's a lot of friction within that liquid, you'd move more slowly. Things would move more slowly through that liquid. So it would have a higher viscosity. So high viscosity is equated to more internal resistance or friction or thicker. Less viscosity is equated to less internal resistance or friction or not quite as thick. Now, we will discuss this later on in future lessons. We'll be coming back to this, but that is your quick, short lesson on what viscosity is.